Today, our presenters will demonstrate how to analyze big data for consumer applications with Looker BI and Amazon Redshift. Let's meet our presenters. Keenan Rice, VP of Marketing and Alliances with Looker, Justin Rosenthal, Chief Technology Officer with MessageMe, and Tina Adams, Senior Product Manager with Amazon Web Services. On the agenda, overview of Amazon Redshift Data Warehouse, how Looker integrates with Amazon Redshift to enable big data analytics in the cloud, how MessageMe turns application metrics stored in Amazon Redshift into actionable insights with Looker BI. So without further delay, let me pass it on to Tina Adams, Senior Product Manager with Amazon Web Services.
Hello, everyone. Thank you for listening today. I'm very excited to go over Amazon Redshift, which is our fast petabyte scale data warehouse for less than $1,000 per terabyte per year. Our goal with Redshift was really to create a data warehouse that was both 10 times faster than traditional databases and also 10 times cheaper. And as a managed service, we wanted to make Redshift very simple for customers to use. So data warehousing done the AWS way is really focused on what is important to our customers. And customers wanted a data warehouse that was easy to provision, that didn't have high upfront costs, and that was compatible with the tools that they use today, including SQL. And so with Redshift, you can get a cluster up and running in just a few minutes, pay only for what you use, and use a SQL or BI tool of your choice. So because our customers wanted something faster, cheaper, and simpler than other solutions, that's really opened up data warehousing to new use cases, which include big data and software as a service. So, we have customers who extend their traditional data warehouse to include data that was way too expensive for them to analyze before. For example, Foursquare streams hundreds of millions of application logs, log events every day to Redshift for its daily reporting. And Redshift is also used by software as a service companies to add analytic functionality to their apps at scale. And another customer, Infor, which is the third largest ERP system, uses Redshift to provide data management tools to over 70,000 of its users. So there's many diverse customers that use Redshift. So we have enterprises, startups, and our customers span many industry verticals, including advertising, financial services, and gaming, etc. And all of these use cases are really driven by what I mentioned before, which is Redshift's price, performance, and ease of use. So as an example, one of our customers, Pinterest, saw 50 to 100x speed up when they moved to Redshift. And Nokia saw a 50% reduction in costs. Financial Times also found that Redshift was a lot easier for their analysts to use. So, this is a little bit of an eye chart, but here you can see that we really focus on delivering features based on what our customers want and need, and we've added many new regions, launched security features, improved manageability and query functionality, and really made it easier to ingest data from many different sources. And again, since Redshift is a managed service, all our customers use the latest version. And of course, we love to hear from our customers on what they like about Redshift, what they'd like to improve, and keep innovating on their behalf. So how exactly does Redshift work? Well, it's a relational, massive parallel processing data warehouse designed to be run as a clustered system. It can scale from a single node to a 100-node, 1.6 petabyte cluster. And Redshift uses Postgres protocol to connect to your SQL client or BI tool of choice. The Redshift leader node, which is a SQL endpoint, stores metadata and coordinates the query execution. The compute nodes are where all your data is stored, and Redshift issues queries at the leader node, which are then executed in parallel by all the compute nodes. And the compute nodes can also be loaded in parallel from S3, from DynamoDB, and from Elastic MapReduce or Hadoop over an SSH connection. And Redshift backs up your data in parallel to S3, and these backups are automatic, they're incremental, and they're also continuous. And Redshift manages the durability of your data by having multiple copies stored in other drives on the cluster. And a final important aspect that I wanted to cover is that Redshift uses Columnar Storage. And what this means is that you get significantly improved query performance because you only read the columns that you need when you run your query. And another benefit of the Columnar Storage is improved compression. So similar columns are together on disk, and you were able to see up to 4x compression with that. When Redshift does make reads from disk, it uses direct attached storage from S3, and that means this drive, CPU, and memory are all local. And so taken together, this means that you're getting as much relevant data as possible from each read and really fast performance. So this table here shows Redshift pricing. And really, we designed Redshift to make it as cost-effective as possible to analyze all your data so that you can focus on answering questions important to your business and not how much it costs to answer those questions. And this table shows pricing of running a single Redshift node, which is 85 cents per hour on demand. And importantly, Redshift doesn't charge for the leader node, so your cost is pretty simple and it's determined by the number of nodes and the number of hours you're using them. We also have a larger node called an 8XL, which is 8 times bigger and also 8 times the price of the single node shown here. And we, a few weeks ago, announced solid-state nodes that are priced at an entry point of 25 cents per hour for a single node. So we're pretty excited about that. And then in addition to on-demand pricing, shown here, you can reserve instances with an upfront fee and pay a lower hourly rate over 1 year or 3 years. And with a 1-year reservation, you get about a 40% discount. With a 3-year, you get 73%. So it can be pretty substantial. And the effective annual price, which I mentioned on the very first slide, for a 3-year reserved instance is less than $1,000 per terabyte per year. And when you compare that to traditional data warehousing systems that can charge upwards of $20,000 per terabyte per year, you know, you're really getting, I think, a great deal with Redshift and can do a lot of different types of use cases. And another important feature of Redshift is its security, and we really provide end-to-end security for all your data. We use SSL to secure the data in transit, and we have a multi-key strategy for encrypting data at rest. And you can have AWS manage your encryption keys or use a hardware security module to manage the keys yourself. And our compute nodes exist in a virtual private cloud, so they cannot be accessed directly. And Redshift can load encrypted data directly from S3 as well. So whether it's over the wire or on the cluster, everything is locked down and secure. And this is the final slide that I have. And really, it's supposed to show that our goal is for customers to use Redshift as a central data store and bring data in from multiple places so they can get a complete picture of their business. And as you see, Redshift integrates with many AWS services and external data stores. So we have some Redshift customers who use RDS, or they run their own SQL databases on EC2 or on-premise. We have other customers that have their own NoSQL databases or use DynamoDB. And Redshift has, as I mentioned, a single SQL integration with DynamoDB and S3. And we also have customers using Hadoop and EMR to convert unstructured data into structured data and then load it into Redshift over SSH. So, you know, there are many ways to get your data into Redshift, and because our customers rely on Redshift as a central data store, you know, having really useful good BI tools is very important. And that's why it's great to have Looker here to describe how they help the customers get a handle on all that data very quickly and easily. And with that, I'd love to hand it off to Keenan at Looker. Thank you.
Fantastic. Thanks, Tina. We're really excited to be here today to give you a little bit of background about Looker and how Looker specifically works with Redshift and how our customers are also finding value out of the entire stack and the innovations that Redshift has brought to the data warehouse world. So, like I said, I'm Keenan Rice, VP of Marketing and Alliances, and today we'll talk about analytics for today's data-driven organizations. So kind of 5 areas I want to cover. I want to talk about the new data landscape, so how companies and databases like Redshift have really changed how people are managing, storing, and analyzing data, where we kind of see a missed innovation cycle in the world of analytics software, the next generation of analytics software with Looker, talk a little bit about the company and some of our customers doing some pretty interesting things, and then finally introduce one of our joint customers, MessageMe, who's doing some fantastic things with the stack. So we've definitely come a long way from the old world of data warehousing and data management. You know, this world was usually looked like, you know, Oracle warehouses, cubes, and complex ETL processes. You know, this world was defined specifically by small data, structured data, and highly manicured measures and dimensions going into the data warehouse. It was one that was very expensive to license and to scale, and one that was very expensive in terms of computing resources. However, this no longer exists, mainly because of 3 key trends. First, most businesses are online or have parts that are online, and they're generating massive amounts of that data, and data that's very, very important to their business and comes in very large scales. 2, raw, detailed data is expected to be available for analysis. No longer is summarized data and static reports going to satisfy the organization. And lastly, database technologies like MPP databases and cloud computing with massive horizontally scalable architectures, you know, have changed what and how we can store and analyze the information. And on top of all these 3 trends, the organizations themselves have also changed and the users within them. The business population has evolved dramatically to be very, very, very data savvy, to be data hungry. They demand access to data on a daily basis, and they want to explore, drill, and even interrogate all the data that they should have access to within the organization. And then we couple this with a new breed of data analysts. You know, these data analysts are really expecting to find the next multi-billion-dollar business or multi-million-dollar business. They're not expecting to service report creation and dashboard creation for the business users. They're very science-focused, and they're used to programming to get answers. But, you know, we've really seen a missed innovation cycle in analytics software. When you apply traditional business intelligence workflow to the new data landscape, you really mess it up. You know, for one, MPP databases go from running on, you know, very, very high-powered computational resources to becoming storage. You get no efficiencies gained by the simplification of the stack. So you still have to build cubes to power the business intelligence applications, which then power reports, you know, which come from smaller sets of latent data. You know, secondly, you have the business users that are going to still be very curious, like we just talked about, and continuously demand data. So this continuously now increases the analyst workload. So now you have the analysts spending the majority of their time servicing the business population when all they really want to do is start solving those business problems and finding those multi-million-dollar new business units. Instead, you know, they're servicing that population. And if they actually do want to go and solve some problems, they don't have the tools necessarily to do so. So we've seen them going back to writing SQL directly against that powerful MPP database. So this really becomes a complete mess. So we thought, what if we could start over? You know, we would build something that was very discovery-oriented, one that gives self-service exploration on complex and large sets of data to an entire organization. One that was going to be much simpler, so one that was going to leverage the power of the new data landscape and quickly be able to be installed, maintained, and administered across the large organization. One that would be very modern, so getting away from the traditional client-server, desktop, Windows application architecture and starting to leverage the browser and modern web technologies. Wanted to be very agile so we can decrease the cycle time between the business users and the analysts and the problems that they're trying to solve. We wanted it to be embeddable. Gartner says that over 60% of all business intelligence in the future will be consumed outside of a business intelligence application. So the data needs to be modeled and it needs to be structured in a way that can then be easily integrated out into applications that line of business people can consume. And lastly, it needs to be agnostic, less about the data layer and more about the value in the hands of the business users and analysts across the organization. So we really built Looker to do three things. One, take advantage of this new data landscape that companies like Redshift are pioneering in Amazon Web Services. Two, empower the new breed of users across the organization, the business users and the analysts. And three, really make businesses data-driven, right? And so we've built the platform of Looker on three key pillars. The first is this idea of Looker inside. So Looker is the only business intelligence tool that is completely architected from the ground up to operate directly in the underlying database. So there's no intermediate cache or data store within Looker. So you have real-time access to your Redshift data. You can exploit the computing power of the Amazon cloud or other clouds as well as Redshift. And there's no need to re-architect or cube any of the data because it wants to take the raw set of information and get that to the end users. Partnering Looker inside with Looker Intelligence is our modeling layer. This is the one that's going to enable the data analysts to extend their value across the entire organization and start working against that complex raw data directly in Redshift. So the data analysts can start modeling data in a semantic layer where they can fold it as complex as necessary without any physical database effort. They can leverage the great analytical capabilities that Redshift has, like hyperlog for very large approximate count distincts, and they can set sort and disk keys for performance across billion-plus row tables. And then lastly, the use of modern web technologies. We have put Git built in, so there's agile team development and version control across the organization. And lastly, this pillar of Looker everywhere. So powerful data discovery for anybody in the organization that can access this complex model of information where they can then share, save, collaborate, they can interrogate, they can drill down to the highest resolution of information, and they can access all the data that they should have access to in an interactive web application across any operating system on any device. So just a little bit about Looker. We were founded in January of 2012 down in sunny Santa Cruz, California. We've gone through 2 rounds of funding. We're post-Series A. Recently, Series A was led by Redpoint, so a total of 18 in funding. What's very exciting about Looker is the statistics of usage that we see across our customer set of well over 50 customers. Is that we see over 60-ish% of every user within the organization has access to Looker. And you really see Looker becoming a daily tool right next to their Gmail or their mail application. How do I access data and how do I access communication is kind of what we see. So we're seeing over 1,200 hours per month per Looker customer being spent inside of the app, exploring through and interrogating information. And Looker itself was founded by some very accomplished and exciting entrepreneurs and innovators. Lloyd Tabb, the founder and CTO, wrote one of the first web application servers, which he sold over to Netscape, and while he was at Netscape ran the Navigator Gold browser team. And while he was at Netscape, did some very exciting things in terms of innovation in web technology, like helping found Mozilla.org, helping write the first WYSIWYG editor, and a handful of other very important web innovations that not only drove the web and where it is today, but also a lot of the architecture and the fundamental different approach Looker has against business intelligence. Our CEO, Frank Bien, was a software executive for his entire career, and lastly was at Greenplum running corporate strategy, and then over at EMC as well, proven big data expert. And then lastly, our founder and operational advisor, Mark Randolph, was the founder and CEO of Netflix, so truly a pioneer in creating a data-driven organization. And lastly, we're very, very fortunate to work with a lot of extremely exciting, growing, and large companies, and especially a lot in technology. And we see these 3 key trends across our customer set that have really shown that this new approach and this new data landscape can provide tremendous amount of value to organizations. So The first trend we see is extremely large data sets. We see customers operating on tens and hundreds of terabytes of information. We see extremely smart data analysts using next-generation data warehouse like Redshift. And finally, we see some of the most complex business models and the operationalization of analytics and data across the company to manage these complex data models. So without further ado, I would like to introduce one of our very exciting customers, MessageMe. Justin Rosenthal, the CTO and co-founder. Take it away.
Thanks, Keenan. Also really excited to be here. Thanks for having us. Like Keenan said, my name is Justin. I'm CTO and co-founder of MessageMe. We're a mobile messaging product. We're available on iOS, Android, and the web. And we've been using Looker for about a year, and Looker paired with Redshift for roughly 8 months at this point. And what I'll go through today is sort of the marriage of those two technologies, show you a little bit about Looker, some screenshots, and one of the model examples. And then I'm going to go into sort of our use cases specifically and how we take our data, put it in Redshift, and ways we sort of slice it up to get the most out of it. And then I'll also mention another use case of ours, which is a Dynamo, DB, and Redshift combination. So Redshift and Looker together as a combo is really about letting your team members get answers to the questions that they come up with on a day-to-day basis and that they pose amongst themselves without having to involve the rest of your organization. So in our case, for example, stickers are a feature of MessageMe that people can send to each other. And an interesting question that comes up is which types of stickers are the most popular. And typically you'd see somebody request this information from the engineering department, the illustrators, the product managers, that sort of thing. And you need to find time in your engineering org then to run these requests and get that back to them. And then if there's another follow-up question, the cycle repeats. And so our illustrators at our company have access to our data model through Looker. They can run these queries themselves. A similar situation that comes up here is SMS deliverability. So we do that to verify users' phone numbers, and we use all sorts of different SMS providers at different parts of the world. And our product teams can actually track deliverability in real time using Looker. And so engineering just puts the data into Redshift, and then we build a model for them, or they build it themselves, and they can answer questions that help us improve sign-up flows and save money without having to bother engineering. So yeah, you can build internal dashboards and create links to various slices of your data super easily with Looker, and that goes on quite a bit at our company. This is an example of just a very straightforward Looker query. So this is charting user signups by day, broken out by the traffic source. So this is sort of a model that we put together, and on the left you can see all the dimensions that you can split by, and then you get a really fast graph, and you can see how quickly you can just modify if you want a longer time range, if you want to filter by something different. That's all really obvious to do in Looker. This is a screenshot of just a Looker model. So this is their Looker markup language, which helps translate your model into something manageable in the UI. So this sort of describes your database, and I just wanted to show this so you can see how simple it really is. This is an easy model, but essentially each of these dimensions is mapped to a column, and you get to describe relationships using this LookML. So that's sort of the Looker part. To shift gears a little bit into data storage directly and sort of answer some people's questions like, why are you using Redshift? I've been using MySQL forever, or Postgres, and I'm happy with it. So from our our standpoint, like this is how we ended up using Redshift. When we launched MessageMe in March of last year, we were splitting our data. All the application data is going into DynamoDB, and all of our statistics data would go to MySQL. And so we would just key the data to each database, depending on whether it was application stats or both. And our configuration in RDS was pretty straightforward. It was nothing crazy. A master extra large and a slave extra large, and very quickly that became a problem. Most of our loading, however, was done in a bulk fashion using load data in file, so we were actually not overrunning our write IOPS at all, even with a small database like the M1X large. However, we were putting in enough rows that our index sizes were getting very large. So a month later, this is sort of what we ended up with, was still a master and a slave, but the slave ended up being a 4XL so that we could get the extra memory. And the master, again, it was fine with the write throughput, so we didn't have to change that. So that was the status like after a month, right? And so this is like a snapshot and some of the math, just sort of back of the envelope calculations on what was going on here in our stats tables. 2 tables, 1 event and 1 message. You have roughly 5 billion rows across them, and the index size is listed there. So like combined here, you're looking at about 200 gigs of index, and the slave that we were using is a 68 gig box. So we couldn't fit our indexes in memory, which meant that querying it was difficult unless you only wanted to look at a portion of either of those tables. If you ever wanted to query the full table, you were in for a really long query. So, and this was after about a month. So we needed obviously much more room to grow than that. So we had to decide what to do next. So yeah, in short, we were putting data in just fine, but we couldn't get it back out the way we wanted to. So the choices that we had were we could summarize the data, which is pretty common. You get a lot of data compression, but you also lose data. And as Keenan alluded to earlier, there's a lot of metrics that people run today that require like row level specifics. And so losing that data and losing the ability to query it was not something that we were really excited about. We could have sharded, certainly. The configuration I showed you was just a single master and a single slave. We could have certainly sharded that into multiple databases. And of course, then you don't lose any data, but now you have problems when you want to go to join, and your querying just becomes more complex. And we're a small team, so certainly your company, like option 2 might be more manageable if you have more dedicated resources, but for us to manage a sharded cluster and keep that running was more overhead than we wanted to deal with. And so the third option, which was sort of question mark at the time, was Redshift. So it was pretty new, and so we investigated, and obviously that's the way we went. So the current system that we're using is actually still a little bit of a hybrid. We do have all of our application data in Dynamo still. That never changed, but our stats data is now split between these 2 relational databases. 90% of our stuff is going into Redshift, and then about 10% is going into MySQL still. And the way we decide where things go is pretty simple. Essentially, Redshift we only use for append-only tables that are okay with putting in lots of rows at a time without any uniqueness constraint. For MySQL, we're doing like single inserts, and we use it for things like purchase tables and transaction logs and things that we absolutely need to know that we're committed and have not been duplicated. So Redshift, you don't have like an on-duplicate key update or those key constraints. So MySQL gives us that. So when somebody spends some money, we put that in MySQL, and almost everything else goes to Redshift. You'll see in the examples there that the bottom table, user demographic, shows up under both columns. And that is because that's the table that we want to join against a lot. How much money was spent in France versus, that would be a MySQL query. Redshift would be how many messages were sent in France. So you're joining against your user table in both. So when you have billions of rows, you can't just query everything all the time, or at least that was the problem with MySQL. And you sort of have these opposing constraints. You want to be able to do deep dive queries and get row level data, but you also want to provide really fast top line aggregates. So how many messages were sent today? You want to be able to answer that really quickly if you can. So the row level specifics portion, Redshift delivers really out of the box. That's what it's designed for. It can crank through billions and billions of rows in very little time. We've seen something on the order of like 1 billion rows a minute, which is great. So your full data set is at your disposal. But again, I just said 1 billion rows a minute. So if you're doing, say you have 1 billion rows a day that you want to look through, you're going to have to wait like upwards of a minute if you want really fast top-line aggregates. And so to us, it's really important to get those to be super fast, especially with a tool like Looker in front of it. You are giving your entire team access to the data set, and the more responsive and quicker they can answer questions, like the more questions that they will answer, just by nature of the fact that it doesn't feel like walking through mud. You can just very nimbly adjust your queries, run them again, dive into the data. So how do we get the top line metrics really fast? We do that 2 ways depending on what the data is and what we want out of it. We either summarize it or we use cache-derived tables. So I'll go into those briefly. The summarization, I sort of alluded to it earlier and said we didn't go this route with MySQL, and now I'm telling you that we're summarizing our data in Redshift. So that might seem odd, but essentially the reason we went to Redshift plus summarization, right, was what I alluded to in the previous slide, which was Redshift gives us the really row-level specific, all my data is available, and then the summarization is giving us the really fast access to certain aggregates portion. So this is an example of the way we're summarizing. This message table we're summarizing into SM message, and you can see with like the data loss by comparing the columns. Right, so you lose like who the sender was, who the recipient was, etc. But you get like 1,000 to 1 compression. And the query at the bottom, how many doodles were sent each day in the U.S. since we launched, is something we run all the time, but variations on that. Split it by country, split it by message type, split it by operating system, etc. And so you don't want to wait 2 minutes for each of those. So the compression here gives us a huge win. We get a couple orders of magnitude faster, and that query goes from 100 seconds to 3 because we are summarizing. And then the other approach is to build these cache-derived tables. Looker actually has support for this built in now, but essentially there are some really important queries that you're going to want to run that demand row-specific data. The aggregates that I was just talking about with the summarization, they don't need row specifics. Who the sender was isn't important because all I really want at the end of the day is a count. However, a query like user retention that does demand row-specific data, and so now you have billions of rows of data, and you actually need to use all the billions of rows. So how do you get queries against that data set to be faster? And the answer to that is usually build cache-derived tables. And what that's doing is you take long-running complex queries and you flatten them into their own standalone table. An example, like I mentioned, is a retention by cohort query. So what this query is doing is it's determining what percentage of your user base returned or took an interesting action 1 day after they joined, 2 days after they joined, etc. And so the query on the left, that's sort of stubbed out, shows you like the general structure, and it's a couple full table scans, right? You're scanning across user, joining it to your message table, and then joining that whole thing with another full table scan. So like that's a costly query, and in our data set, it can take 8 to 10 minutes or so in Redshift. But what we end up doing is we select this into a new table. So something really useful about this type of query is that the data only changes every 24 hours. Since it's a daily retention query, once you tick across midnight, like the data for the previous day is frozen. So it's great if you can just run this query once and then you freeze that for a day. Like I said, Looker supports that now without you having to write like your own background crons to build these tables and things. It can generate the temporary tables on your behalf as long as you just describe it. And then at that point, you now have its own table, which has its own model in Looker. And so as far as Looker is concerned, it's just regular data, and you can slice it and join it against all your other data set the same way you can everything else. So that's the way we approach taking as many rows of data as we have and combining them into, or sort of massaging it into something that makes it really effective for your team to analyze, whether that's getting top-level aggregates or getting complex results like retention. So the last thing I'll sort of mention is that we also use DynamoDB in conjunction with Redshift, and that has become actually a really interesting use case for us, in that all of our application data is already in Dynamo, and application data by its nature is sort of this heterogeneous blob of stuff. Like you have a bunch of strings and phone numbers and addresses, and then counters and who knows what else, whereas your stats tables are typically really homogeneous. It's a bunch of integer columns. So it is very typical to use a separate data store for your statistics, which is sort of what I talked about earlier. Application data was going in Dynamo, statistics was going in MySQL, and it's for that reason. You don't want to have to store all these big strings and blobs and stuff in your stats tables, because it'll slow down your query times. However, Redshift has an interesting feature where it can load from Dynamo, and occasionally there are interesting queries that you want to run against your application data. So we were running a college campaign last year trying to boost MessageMe usage in schools, and so we wanted to know how many users were signing up with education email addresses. So that data was all in Dynamo, not in Redshift. And so what we were able to do was actually to essentially with a single line just copy our user table from Dynamo over to Redshift, and this is like a bulk load process, sort of all or nothing, but it parallel loads this whole table. And then once you have the table in Redshift, you can run your regular SQL queries. You can do wildcard matching and like clauses and things like that against email address and whatever other strings you might want. And then you can actually make that available to Looker as well, which is what we did. So we had like our regular user table in Looker, which was sort of like user IDs and demographics. And then we were able to just very easily join that against our Dynamo copy, which was sort of like user metadata. At that point, we could tweak the Looker interface so that if there was like a certain cluster of users or the result of a query, we could actually dig in and split out like by email domain if we wanted to see where those users were actually signing up from. So that's how MessageMe and my small team use these two products. Redshift makes all of our data really available and really fast, and Looker adds this layer that allows the whole team to peer into that and answer their own questions really, really quickly. And that is all. I'll hand the mic back to Maya to, I guess, do some Q&A and wrap us up.
Thanks, Justin. And thank you to all our presenters for taking the time to join us today. This concludes today's presentation on how to analyze big data